it, right? For the recording purpose. Um, Hello, welcome everyone to the course Introduction to Big Data Ecosystem. This is the first offering for the course. So this course is very new. Hey, hello. Hey, hello. Oh my God, it's so shiny. Hey, hello. Hello. So this is the first offerings for the course. So this course is very new. There could be some things a little bit strange or weird. So I will try to make it as smooth as possible. Okay. But since it is very new, if you have any suggestion or any comment, concern, feedback, please feel free to reach out to me. Or if you're afraid to talk with me for some reasons, talk with P1, okay? Or talk with other students and let other students speak up to me. That is totally fine, but I don't think you need to be afraid of me. Okay. Well, this course is going to be pretty relaxing. It's an elective course, you know. This is an elective course. So I'm not going to be like very nitty gritty like in the fundamental course, like the database course. Okay, that one is a fundamental. So I just want you to get a solid understanding. That is why I need to be very nitty gritty. But for this course, it's an elective course. So I'm not going to have like, I'm not going to, um, should say, I'm not going to like expect a lot from you. I do expect that you're gonna learn a lot of things, but I'm not gonna expect a lot. So it's your own decisions. Okay. We just have one goal for the course that after you like after this course end, we should be able to build something relevant or related to the big data. That is all we want. So that is why this course is gonna have a lot of workloads and be prepared, okay? Be prepared. Right. Um for the third year, I think that when I taught you database, it's not gonna be we don't have a lot of work. We did, but comparing to the second years, I think for the second years I did I did assign you a lot of works. So um there will be a lot of work, but as I said, this course is very new. So if you think that there are a lot of work, tell me. Okay, so that I can adjust it for you. Right. Now, just to introduce yourself, my name is Guy and I'm a PhD candidate. I just got like so so the thing is like in the at the Carnegie Mellon universities in my university right now, when I'm during like my time as a PhD, if I just like enroll to enough course, I can also redeem my master. And I just redeem my master for the sake that I just get the degree, master degree out of it, right? Anyway, I also like an alumni from the KMITL as well, from the computer science. Um, my technical interest is more on query processing and optimizations, which is about database. You all have known about it, right? And I also interested in the high performance database systems, or database system that is fast. Okay, just love making things fast, you know. Okay, so we do have hey teaching assistant. Sorry, I just borrow this picture from your Facebook นะหนึ่ง Uh, so หนึ่ง he is like fourth year computer science student. Perhaps this is his last semester. He has been like my teaching assistant for the previous database course, and this semester as well, because this semester I handle like two courses, at least two courses, which are the first year database course and this big data course. So all I can say is Ning will help me facilitate this course in many ways. Many ways here means many ways. I don't have a good definition for the word many ways here. So, you know, um, so it depends on how much you interact with P1 and how much me interact with P1, right? Okay. For the sake of the logistics, we do have a meetings on every Monday. Whether it's going to be a lecture or the lab, you can check it on the website, the schedules. So if it is a lab, you need to bring your lab computers as well. And it will be on Zoom for the first 4 weeks. So it will be like this for the first 4 weeks because I'm still in the States. But as you can see, I booked my flight. My flight is on 18 December, which means after the fifth, starting for the week 5, I will be in Thailand and I can deliver you the lectures on site, the lab and the lecture on site. I hope it's gonna be more fun. I mean, being online is not that fun and entertaining. Okay. Well, simple rules. Just interrupt me if you cannot follow me, or if I say something you don't understand, or you have any questions. I know that most of you not gonna interrupt me because I mean we are Thai people. Most of us are Thai, and Asians, um, and Asians. Most of the Asians. I'm not gonna say all of them. I'm not gonna like stereotype it, but we do have some culture that we are not gonna speak up. That's include me as well. When I in the lecture room, we just like afraid that it's gonna interrupt the flow of the class. What I want to say is, I mean, that's fine. That's fine for feeling that way. You just ask me on forum, okay, if you feel that way. But if you don't feel that way, if you're just like, okay, I'm gonna interrupt it because perhaps my question is also what other people is thinking about as well, are thinking about as well. So they gain benefits as well. So just interrupt me, okay? Open up microphone, text on the chat. That's fine, right? Or maybe like just raise your hand and then call พี่หนึ่ง on in the room and then say that, oh, do you have the questions? พี่หนึ่ง, if he cannot answer it, then he gonna text me or speak up to me. Okay, so just feel free to do it, right? Again, this class will be very relaxing. So I don't see whether there will be any problems on asking me questions, right? And I'm not gonna be like, this is stupid question. No, no, for me, all questions are not stupid, right? So just ask, right? Just speak up. Okay. Oh, it's a very good, quick introduction because you all have already not, you all have already known me, so I'm not gonna speak a lot on it. So this class, the name of the class is Introduction to Big Data Ecosystems. This lecture name is Introduction to Big Data, which means we're going to talk about the thing called big data. Not sure whether you have heard about the word big data or not, but the word big data was like very popular in the past decade. In this decade, you can still heard it out, but um, I would say that it's less popular than in the last decade. In the last decade, many people just say, "Oh, I'm gonna do big data. I'm gonna do big data. I'm gonna build a project on big data." It's like a buzzing word. It's a very buzzing word. Why? Why people do say about big data? So, based on the word big data here, what you can infer is, okay, it is definitely a data. And you know what is data, right? For third year, the word data, I believe that it is one of your exam questions. So you need to, you know it. For the second year, I'm not sure whether I have told you the definitions or not. Uh, I think I have. I had, but yeah. Anyway, just recap it. The word data, it's not data and database are different, but they are related. Data means fact or information that you can use. Well, yeah, it's basically a fact or information. That's it. That is the definition of the word data. We usually use data for doing decision making, not not a simple decision making, but like a precise or an accurate decision making. So imagine that you are running a business, right? And you are deciding whether you should like sell product A or B. Without data, you just use your gut feeling. You just use um your luck, right? You bet your business on luck. That is without data. Or maybe but with your maybe other luck, something like that, along that line. But if you have data, perhaps past experience, right, from yourself, or maybe the history of the sales for like similar products, then you can make better decisions, right, with data. And the good thing is, if you have a lot of data, then it is likely that you can make a more accurate decision. So that is why you have the word big here. I mean, big here is not our K-DAI. What is his position? K-DAI, head of K-DAI, right? The big here is not about Ajahn Akade, Big here means large, huge. So basically, a data that is huge or large, which is the term is very simple, right? The term is like, okay, we just have a data that is very large. That's it. Okay, yeah. That's all for this lecture. No, just kidding. So let's be more precise about this terminologies. So back then, when the word big data was coined, there is like a company called Gartner. Gartner is the company that do many things. One of the things that they love to do is to define some things in the tech. I believe it not only in the tech field but in other fields as well. But they love to define things, and one of the good things for the Gartner is that they have like they're trying to develop a visualization of which technology is booming right now, which technology is getting adopted, that in this year, which technology is going to be out in this year, something like that. And I believe that is very useful. And I feel like many tech businesses, they use the Gartner visualization as the guideline for, preparing themselves for the next year or for the upcoming years, or getting themselves like stick to the trend of the world. Right. So Gartner, when we have the word big data, they're also trying to term this word, right? Add something like big data is high volume, high velocity, and high variety, blah 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 blah. So if you have time, just read it, okay? But for me, the key term is that back then, just on the previous slide, the word big data is just data that are large. So we are focusing on volumes, right? Back then, let me using the laser pointers, right? If we only like think about the word big data, most of us would think about, okay, the data is high volume, right? But Gardner saying that no, volume is not enough. Volume is not the only challenge. Velocities and varieties are also two other challenges with big data as well. And this is a point. This means that if you are working with data that are large, you have at least these three challenges. Data going to be in high volumes, data going to be in high velocities, and data is going to be in high varieties, right? So you need to get aware of all of this thing, not only the volume of the data. And okay, volume, velocity, varieties, they are all starting with letter V's, right? So that's why many people call it, oh, this is the three V's, the three characteristics of big data. Yay, woo! People like many people love to terms the word as like, okay, I'm starting with the same letter so that they can say, oh, it's 3V, 4V, 5Vs, right? Yeah, never mind. It's just like some people love to do that. I mean, it's good that it makes us easy to remember something as well. Right? But for big data, people just love to coin it. People just love to, oh, it's okay. We have volume, velocity, varieties. Oh, we do need to consider values of the data as well. We do need to consider variabilities as well. We need to consider veracity as well. We need to consider visualization as well. So eventually we got 7 Vs. Um, in this course, I'm not going to talk about variabilities, veracity, visualization, and values. Um, it's not that they are not important, but I just at least want to stick with the three main characteristics, three main challenges, so that um, you understand them clearly, and you can build some things, build a solution, deliver solutions that can solve or tackle those challenges. Right? Any questions so far? Anything you want to ask me? Any feedback, comments, concerns? So far, good, right? Everything is good, right? Yeah, I mean, since it's just online, so I just want to ask like for feedback, um, occasionally, not occasionally, it's like for feedback, like so that I know that you still like understand me or you still up. Okay. So yeah, I hope you understand this part, right? Okay. So now we know that big data, we have three main characteristics: volumes, high velocities, high varieties. Right. Let's talk about each characteristics of big data. High volumes, which means many systems they need to if they are working with a lot of volumes, a high volume data, then they're gonna meet some certain challenges. They're gonna meet a certain challenges. For example, Discord. You know, I believe that most of you have used Discord before. Discord, how many people use it? Okay, I'm not sure. I'm not sure about this number, but based on the number of people, each people takes message, right? They take some messages, right? Back in 2023, Discord they claiming that they need to store trillions of messages, millions messages. That's huge. That's more than the numbers of humans in the world. You know, the question is how. Let's say if you are a developer or an engineer in Discord, how are you gonna store them? Trillions of messages. How? Anyone can give me some ideas based on given all of your knowledge so far. How are you gonna store trillions of messages? Any idea? iCloud and Google Drive. I remember iCloud just allow us to store like I mean if it is a terabyte then I believe you, but if it like trillion of messages, okay, trillions of messages. Let's say each message is like 100 bytes. 100 bytes is that's too optimistic as well, but let's say it is 100 bytes. Trillions, 10 to the power of 12, 10 to the power of 15 bytes, right? 10 to the power of 12 messages. Um, time 100, which is 10 to the power of 15 bytes. 10 to the power of 9 is gigabyte. 10 to the power of 12 is terabyte. So you need to store at least 100 terabytes. And I don't think iCloud and Google Drive uh gonna allow us to do that. But that's a funny answer. I know that's a joke. Any ideas? Any other ideas? Yeah, I mean, you could store it in a system, but how? How are you going to store it? Which kind of system? Okay, let me break down the question so that it is easier for you. Do you think you can store these trillions of messages in a single computer? That's my first question. Do you think yes or no? Potentially no, right? More typical computers. I believe I can store only a terabyte of data, and we have like 100 terabytes. Pretty hard, pretty hard. Um, so which means we may need to have a very powerful computers, right, to do it, or something else. But maybe hundreds of terabytes may be too optimistic. There's someone, and there's someone predict that we're gonna reach 10 to the 24 bytes or zettabytes soon, or yottabytes soon in 2040, which is definitely in your lifespan, right? In your lifetime. How are we gonna deal with yottabyte? How? Oh my god, this is serious, right? That's the challenge of data with high volumes. That's a challenge. That's a challenge. You know. The next question is, oh, come on. We are in Thailand. We are in like we don't have this much data. You know, Yota, why you need to have like you need to gather data all around the world. Okay, that's fair. So maybe the next question is that to ask is that for you, or maybe for me, how much is high volume? How much high is high volumes? When should we consider data as high volumes? Trillion of messages? Yeah, that's high volumes. Just that bytes, that's high volumes. But how about the others? How about like other scenarios? Maybe you open a business, you have like millions transactions per day. Do you think that is high volumes of data, of the transaction data? Perhaps, yeah, it's millions, you know, millions is a lot, right? But for someone, millions maybe, oh, it's not that much. Come on. So when should we consider data as high volumes? So let me leave this as a question. Okay. You think about your answers in your mind, okay? Right. One of the possible answers is that perhaps you can consider data as high volumes when it cannot be fit in one machine. I mean, if all the data is still fit in one machine, then I believe that you all don't see much problem on it. Okay. But if you are reaching the point that, hey, I'm opening up business and my business cannot store data in that one machine anymore. So now we need to buy more machine, or maybe we need to upgrade the machine or something like along that line. It gives us a challenge, right? So this is one of the challenge. When you have a lot of data, typically you cannot store it in a single machine or a single computer anymore. One of the another challenge. So let's say you are able to break down your data and store it in multiple machines. So let's say you are a company, you buy like hundreds of computers to store data. So now you have hundreds of computers. When you have a lot of computers, it increases the likelihood of some of your computers may be broken, maybe unavailable. It's maybe crash. And if one of hundreds of your machine are crash, some of the data are unavailable, right? Let's say you are um let's say you are banking system. You are one of the banks in Thailand. And at that moment, you are unlucky because let's say at that moment in the bank, they store like your data in multiple machines, and one of the machine failed, and you are unlucky that your account data is on that machine. You cannot buy things at that moment because your data is unavailable. That is critical. You don't want it to happen. Okay. Any questions or things? Never mind. So if that's the case, You don't want that to happen. That is a very critical, right? Sometimes that at that moment you need to purchase something very important, but you cannot because bank one of the machines in the bank failed and it contained your data. That is another challenge when we try to break down a data into and store them on multiple machines, right? The last one, if the data are across multiple machines, given your given your background, given your knowledge, your Python knowledge, I'm not sure whether you have learned about other things or not. How are you gonna, let's say if I want to see like an average of all the balance in all the accounts and I store them in multiple machines, how am I gonna write a program so that I can calculate things from multiple machines? That's another challenge, right? Because so far I believe that you have like learned how to write program for a single machine. That's fine. A single machine is fine. Not that hard. It's just Python or maybe other programming languages. But for multiple machines, that another level. That's another level. For challenge number one of the solution is called horizontal scaling. So the word scaling, we have like in the world, we have two ways to scale. Scale here means that to allow your system to like handle more load or more data. So load here, load in this meaning is the number of data. So how are you going to handle more data? There are two typical ways. The first way is you increase the you upgrade your machine so that it can store more data. Maybe you buy more hard disk, maybe you upgrade you increase the capacity of the hard disk. That is called vertical scaling. Vertical scaling is that you upgrade your machine so that it is better and it can handle more scale, more load. But at some moment, you will reach the limitation of what one machine can do. You need to break down to multiple machines. And if you break down to multiple machines, that is what we call horizontal scaling. Okay. But with horizontal scaling, okay, you just buy more machines. It doesn't help. You also need to break down your data into multiple partitions as well, and then put each partitions on an appropriate machine. So that is another one here, which is data partitioning, which means if you want to deal with the first challenge, you need to do data partitioning and do horizontal scaling. Okay. For the second one, I talk to you, okay? Let's say we can do data partitioning, we can do horizontal scaling. We break down, we have a lot of data, right? We break it down into onto multiple machines. And let's say one of the machine fail, and you are unfortunate that at that on the you are unfortunate that your data that you are want to use is on that machine. You're not it means that you are not be able to use a system. And for a very critical system, that is very serious. One other solution is that so if one machine fail and you cannot access your data, why don't you just replicate the data on one machine to multiple machines? So instead of your banking, your account information is only on one machine, you distribute it onto another machine as well. So it is safer, right? It is safer. The solution for the sharing number two is called data replications. Are you trying to replicate data across multiple systems? So there is a student asked me to explain more on horizontal scaling and partitioning. So I believe that it would be better if I draw pictures. Let me open up my iPad and um let's see whether I can give me a moment. Okay, I think drawing it might be a lot better. Um, again, just feel free to ask me a question if you don't understand, right? That's totally fine. Um, Share the screen. Share the screen to MacBook. Oh my gosh. Give me a moment. Okay. And then I'm doing this. Okay. And then I need to reshare my screen. Okay. Move, 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 move. Bro, move. Okay. Okay. So okay, can you see the screen? My God, it's getting streaming. Wait a bit. Okay, that's just a lot better. Okay, can you see the screen? Okay. So, when we talk about horizontal scaling and data partitioning, it's like this. So let's say you have a lot of data, right? Can you see what I wrote on the screen? Yeah. So we have a lot of data. I draw it in this as array blocks here, as array block here. This, let's say it's like 10 terabyte of data. And your machine, let's say for each machine, you can store only 2 terabytes of data. You have 5 machines, for example. This is one, right? One of the way to make you be able to store this 10 terabytes of data onto a machine is you may consider upgrading this machine. Maybe you upgrade this into so that make so that you can make it store like 10 terabyte. Maybe you buy more hard disk, put it onto the machine, or maybe you buy like a better hard disk. If this machine can store 10 terabyte, then you can put all 10 terabyte into this machine, right? And that's good. This is called, if you increase the size or the capacities of the machine, then this is called vertical scaling. Okay. But, but sometimes this is difficult. This is challenging because I believe a 10 terabyte hard disk, it's not easy to find, you know. And sometimes if it is easy, then it's perhaps be very expensive. So alternatively, let's say you have 5 machines. Each machine can handle 2 terabyte of data. You may want to first break down this data into maybe 5 chunks. Each chunk is 2 terabyte. Now you can store each chunk into each machine, right? To break down data into chunks, we call this data partitioning. And to upgrade the scale. So vertical scaling is to upgrade the scale of the system by increasing the capacity of one unit. Horizontal scaling is you upgrade the capacity of the system by you increasing the numbers of machines. So here we increase the number of machines instead of one, we have 5 machines. So this is to improve the scale by buying more, using more machines. So it is something along this line. Scaling, vertical scaling and horizontal scaling are about how do you improve the scale of the system. So that two-way. Vertical scaling, upgrading your machine. Horizontal scaling, buying more machines, using more machines. If you want to do horizontal scaling or using more machine, you need to be able to break down your data or partition the data into multiple partitions or multiple chunks. And we call this technique data partitioning. Is that clear? Okay, cool. Again, if you have any questions, just feel free to ask me, okay? I need mouse and then clear all the things. Then let me bring back the slide. Oh my God. Okay, cool. I'm not sure whether the size of the slide is smaller or not. Can you still see the slide clearly? Uh, well, never mind. Just want to make sure. So just gonna stop sharing and then just to make sure that it is good. Let me reshare it again. Next time I will set this up better, okay? I'm so sorry about this. Okay, so that's about the first solutions, right? Data partitioning and horizontal scaling. The next one, when you have multiple machines, it is more likely to that one of the machine will fail than you only have one machine and it will fail. So one of the solution is why don't you just instead of having one copies of your data on one machine, you copy the data as multiple copies and you store it in multiple machines. So that will help making your system more have more availabilities. When we say the word availabilities here means that whether the system can provide the data that can make the data that we want available or not. Okay. For the third one, if you use old programming method, like you write a Python program, a simple Python programs, maybe you write C programs, you write like a normal programs, you will not be able to use data from multiple machines, right? You need to have a new way. And the next solution is to have like a distributed programming models or maybe an approach to programs data to write a program that can use data from multiple machines. Okay, so these are three main challenges when we have high volumes of data. Is this clear? Any questions, comment, concerns? If I ask you this in the final exam, you can answer it, right? But well, my final exam will be I so right now I'm still working on the final exam. So I haven't finalized the final exam. I am thinking about two ways, right? For the final exam. First way is you see like a question same as what you have done with my exam before. Another way is I may provide you like only one question for the final exam. And you need to gather um you need to like gather all your knowledge from all the lectures in order to answer the questions. So there are two ways right now that I'm thinking. I haven't finalized yet, but maybe after I meet with all of you on site, I may ask for like what are your preference. Okay. But I mean final exam just 20%, so you don't need to be worried about it. Um expand the last one, distributed programming models, right? The last one here. So Basically, it is like if you use the traditional method for writing a program, you only can use the data on your machines, right? You can only access files on your machine. But if you want to access data or files from multiple machines, then you may need to have another way, a different ways to write a program. That's it. That is all about that. That is the meanings of this last one, the last solutions. I mean, I believe that some of you may know the way to do it. In this case, I'm introducing you to another way, a different way. But you don't need to stick with one of the ways, but you need to know what is pros and cons for different ways of of writing a program that can acquire data from multiple places. Okay, is that clear for the last one? So that's pulling that's pulling data from GitHub or GT. You could say so. You could say so. Distributed here means that data are distributed. How do you have the way to consolidate them together? Or not, you don't need to consolidate them together, or you would like to process it, maybe compute it based on data from multiple locations. So pulling data from Google Drive or GitHub, you could consider it as distributed programming as well. Maybe the word models here, the word model here means a a concept, a concept. It's just a concept, but doing like GitHub or Google pulling data from GitHub, you could consider it as a distributed programs as well, programming as well. Yeah. If you talk about this with some people, they might say no, but for me, yes. I mean, because I mean, there is a way to teach you distributed programming model. There is a standard way to teach you that, and people just love to teach you about something that they call map reduce or Spark. So in which I'm gonna teach you them too as well. But and people just some people just stick with that. Oh, distributed programming means Spark and MapReduce. But for me, no. It's just like the key principle is just you gather data from multiple places. Maybe you would like to compute data from multiple locations as well. Okay. We're gonna talk about the third one later on, and you will see you understand it clearer. Okay. If you still don't understand it, post question on forum, right? I will answer you like with more details and more examples. Okay, but feel free to post a question on it, and then Poom will smile because he dedicated a lot of times on building forum. He would love uh us to use it a lot. Okay, right? Is that clear? Okay, cool. If it's not clear, then ask me more on forum. Okay, right? Next one. Oh my god, that is only volumes. Volumes. Data with high volume. At least three challenges that you need to deal. Okay. Varieties. What do you mean by data with high varieties? It's like is that like okay, we're gonna have like well before okay, let me do it in this way. Do you guys have any ideas on how data can be varieties? Maybe you can you guys give me like some example of data with high varieties based on your perspective of you seeing this very different data types like int, float, strings, right? Having many things. And any other examples from all of you? For me, different data types, yeah. Those are like varieties of data, right? Any other answers? How about this? So let's say you open up Facebook. I'm not sure how many of you still use Facebook. Okay. Let's say Facebook. Oh my God, that I'm feel a little bit old right now. Facebook allow you to post text, right? Not only text. It's also allow you to post a videos, a what else? A picture, many like many things. Can can we consider them as like data with high with varieties, a varieties of data? Yeah, right. So in terms of big data, different data types, um, it could be a variety of data, but there's something much more challenging. So before we get into the challenge, this is one thing that people in the big data field they they love to treat this as a high variety of data. So people usually categorize data. One of the way to categorize data is to categorize them into these three categories. The first one, in which you should be very familiar with it because you all have learned with me, which is the structured data. Okay, the table, DuckDB things, you know, table that you can get data if you load this table onto DuckDB, right? And then you know, and then you use SQL, your beloved SQL, to extract data from it, right? So this is structured data, but it doesn't need to be SQL. Can be pandas, right? Can be what else? Excel. You use Excel and then you just like um use Excel functions or Google Sheet functions to extract some insights, right? Structural data, very easy to handle it, because it have most of the structured data, it have they have a fixed schema, fixed structures, right? Let's say you are working with a table. You mostly need to know like, okay, what are the columns that you can access so that you can write, so that, okay, I would like to find average age. So that okay, I need to access the column age and then aggregate them into a single values, right? So this is very easy to handle structured data. For the second year, you have done the Sun Bear, right? The first assignment that I assigned to you for in a database course. You are lucky that the data are just table. If the data is not a table like this, you will have a lot of hard time to deal with it. It will be very hard to implement the programs to deal with the data. And that is the next two one. So I go from the right to left. That's because of the picture that I found. It's going from right to left. The next one is okay, what we call semi-structured data. What's the difference between structured and semi-structured data? So structured data, you need to well, let me tell you this. Structured data doesn't need to be table. Most of them are tables, but they are just a data that the fixed structures. You know that you know the number you know the all the columns in advance so that you know whether you can access you can get you can gather a certain data or not, right? For semi-structured data, it seems to be structured in a certain way, right? For example, this is written in a format called XML, right? I believe that it stands for Extended Markup Language. So this is written in XML. An alternative semi-structured data is called JSON, JavaScript Object Notation. That is another popular one used in many websites. So XML and JSON, they are called semi-structured data, even though you know the field, right? You know that, hey, student, we have name, age, degree. Student name, age, degree, and ID, right? The point of semi-structured data is that it is possible that you write another student and you may remove some field or add new fields into it. That is possible for the semi-structured data. For the structured data, if you want to add a field, you need to add a column. which means all rows you have this you have like a cell or a field for all the rows with the new column that you add. For the semi-structured data, you introduce another student with maybe you have another field called enroll date, something like that. It is possible. And it is possible that you don't need to add that field onto other students as well. Right? So you see that the structures is not that clear anymore. It depends on each object here, each entity is here, whether how much characteristics or how much field you want to add. That is about semi-structured data. For example, JSON or XML, right? And the last one, unstructured data. Unstructured data basically means you have almost no structures. Even maybe you could have a structure, but you cannot get any clue from the structure of the data. You can get only a few clues from it. Or basically, there's no structure at all. Like this one. All these three data refer to the same information, same piece of information. But they are structured in different way. I mean, the last one, maybe I cannot say that it is structured as well. You know. So let's say, based on these three data, if we ask you, can you get the age of David? Which one will be the easiest? Uh, which one, which categories of data do you think that you can gather, you can answer my questions the easiest? Again, the question is, let's say if I want to get the age of David, based on given these three data, right? Structured data, right? Because you just need to, okay, search for David and then look at the age column, right? So with structured data, okay, it's still doable. I mean, okay, we just need to run through each student and see whether there is David or not, and then you find the age, right? But you may need to read a lot of text. See, there are a lot of text that you need to read. But for the unstructured data, you need to read like all the words and you need to interpret it as well. So you see that for unstructured data, there will be like an interpretation part that you need to consider. What I want to show on this slide is that we have different ways to people store data in different ways. Each way they have their own way to deal with it. We need they have different challenges. Some are easy, some are difficult. And in real life, you see a lot of unstructured data, right? People like us communicate data unstructured. We text message, our text messages are unstructured data. We not text like this table, right? We're not like, okay, when I send you a message, I send you a table. No, we didn't do that. We do not do that. Right? We love unstructured data, but unstructured data is the hardest one to process. This is just like a definition from IBM. Structured data has fixed schemas and fit neatly into rows and columns. Fixed schema is a structures of a database structures. Okay, database is a collection of data, a organized collection of data. So basically, it's more like you need to know the columns of the data in advance. So you can call it is a fixed schema. And when there is a word fixed here, it means that the columns are unlikely to be changed. The columns are unlikely to be changed, which means you would expect that this table will have like, let's say initially it have 5 columns. You would expect this table to have 5 columns all the time until major changes. That when I say major changes, it means that it shouldn't have like, it shouldn't be a lot, you know. For unstructured data, it has no fixed schema, no structure at all. it both structured and unstructured data can contain the same information, same piece of information. But since it has no structures, then it is very hard to check, to extract the data, the information that you want, right? So for varieties, I pose you two challenges. The first one is that is it likely that when you have more data, the schema or the structure of your data is evolving? Maybe at first your table will have 10 columns, but with more data, you see that it is better to have more columns, more columns, more columns. Or for the newer data, some of the columns should be dropped. The schema is keeping the schema keeps changing, keep evolving. So this is one of the challenge with a lot of data. Okay. Or sometimes you cannot predict the schema at all. Right? You got a lot of text pulling into pulling onto you. You don't even have the way to predict the schema. You don't even have the way to make it structured. That is another challenge from high varieties of data. Okay, when the schema is evolving, how do we deal with it? Can we use DuckDB to deal with it? Can we use the good old relational model that we love to deal with it? My answer is yes, but it will be burdensome. You need to, okay, now we are going to use this new column, then we need to add more column. Even though there is only one piece of data that has that field. Imagine that you have like a millions of rows in a table, and the new rows you want to insert like a new field onto it. If you use DuckDB or relational database, you need to add one more column. And when you add one more column, you need to add it for all rows in the table. Is that efficient? Okay, you add one more field for each row in a table in order to add new values that is introduced from like a new data that we're trying to put it into the table. That is not efficient at all. All right. So alternatively, we can use the data model that is more flexible, like the document data models, key values data model, key values. That one is not that flexible. But document data model. Document data model is basically you store data as JSON. You store data as XML. This one. So let's say if you want to add new student with new field of data, you just need to add new student with an additional field. That's it. Right? You don't need to modify other student data at all. Right? So that is what we call a flexible data model. Right? Or the data model that is more flexible. One of the examples is a document data model that basically we store data as JSON or XML. Another one is the graph data model, the property graph data model. But the flexible data model here, it really depends, Sometimes when they say graph data models, some of the system that implement graph data model, it doesn't allow us to have flexible schema as well. So you really need to, it really depends on data, on the system as well. This is what you need to consider when you choose technologies. All right. If the schema is unpredictable, you may want to just store it in something that it doesn't care about the schema, but you need to have the way to store it, right? So one of the solutions that we love to store data that is unpredictable and that doesn't have structure is we would like to store it in a blob storage or the file storage or the file system. Blob storage. Oh, this is a new term, but I believe that you all are very familiar with the blob storage. Blob storage, basically Google Drive. That's it. It's basically a Google Drive. It's just like a place that you can store a file or an object. That's it. Google Drive is one of the example. Google Drive it is good for typical users, non-technical users, because they are easy to use. But for like a very technical users, it doesn't provide any interface that you can use it to write a programs on it, right? It is very hard if you want to program with Google Drive. So we will learn about another technology that it is a lot easier to for you to write a program, to use it. Okay, that is about varieties. Any questions, comment, concerns? Oh my god, honestly, okay. So this is aside. Honestly, I thought that this lecture will end within an hour, but I think that we're gonna go like maybe 2 hours or something. These are questions. So if the schema is evolving, then we can use semi-structured data to solve this. The answer is yes. And that is why we're talking about flexible data models. The system that implement flexible data models are mostly store data as semi-structured in a semi-structured manner. Okay. So basically, you can think about it as, okay, we're going to store data in a semi-structured way, right? Any question, comment, concerns before we move on? Yeah, true. I haven't said that semi-structure is bad. It is slower if you want to process data or if you want to access data. It it's typically going to be slower than structured data. That is true. But if you know that you're going to have a lot of data like pouring into you, and those schema they're not that obvious, or schema are like just evolving, then perhaps you storing the data as a semi-structured manners might be better. So it's like there are trade-offs between each way. That is one other thing that I would like you to learn from this course as well. In this course, I'm not gonna say that this is bad, this is good. But if I'm gonna say that this is bad, I'm gonna say that this is bad under these conditions. This is good under these conditions. Because most of the things that we're gonna learn in this course, they have trade-offs. You know. Okay, is that clear? Cool. Next one. Yeah, we now like in the third one that we're gonna cover in this for this course. Velocities. I think that varieties is a little bit hard to interpret than velocities. Velocity means the speed, right? I mean, if you are a physics guys, you're gonna yell at me that hey, velocity and speed are not the same. But basically, it's just in that way, right? It is like how much, like it is a speed of data. But speed of data, what do you mean by the speed of data? Can data run? No, cannot run. So high velocity. What does it mean? Basically, it means that imagine Uber in Thailand gonna be Grab or Line Man, right? Um, how imagine in your lunch time, many people order foods. Many people like use these applications. The numbers of data, the number of data transaction that each people have made, it made data, right? When you order something, you generate a data. You generate data. Those data, they are incoming to the Uber system or the Grab system, Lineman system, all at once with a very high rate. That is what we call high velocities. Data are the system are ingesting data a lot, right? There are a lot of data pouring into the system. That's a challenge. So, and for Uber, you know, for each day, they process 35 petabytes of data. Holy God, 35 petabytes. Petabytes. 1 petabyte is 1,000 terabytes. 1,000 terabytes is 1 million gigabytes. So basically process 35 million gigabytes every day. That is a number of data incoming to Uber. Definitely introduce new challenge. How are you gonna handle them? Your computers has limited capacities. Your computers cannot handle this type of data. You at least need to use multiple computers to handle it, and that is horizontal scaling, right? But even though you have enough power, I mean, okay, first, it could be very hard to get like that kind of power to handle like all of this 35 petabytes every day. Maybe it might be better that you may want to just, okay, you get this all of this data. Some of the data may not be used right away. Some of the data, like the order data, right, the transaction data, those must be used must be used right away. You may want to prioritize those data in use first, because when you order something, you want this data to be updated on your phone, right? You want to know, okay, this is like where like the driver is uh where the driver that you just that you just book right now, right? You want those data, right? But for some, they could be some of the data that you don't need to use it, right? Uber doesn't need to process it right away. So Uber, they need to prioritize some important data that must be processed first. Then some of the data that it doesn't need to process right away, they can just put it aside put it aside first. Which means, but you need to know that data is already coming. So you cannot just ignore the data. You need to at least stage it or put it somewhere else. You need to put it into some buckets first, right? That is what we call data staging, right? You just stage the data first before you putting into like the system that gonna process the data, because you need to prioritize some workloads first. That is the reason. Given the data is coming a lot and a lot, okay? You may want to prioritize something first, some data first, rather than another group of data. And the solution is you want to stage it somewhere. You want to put it aside first somewhere. And then once you have time, like Uber, at night, Uber not gonna have a lot of orders. Then at that time, we're gonna process these leftover data for each day and bring it onto the system. And the process of bringing these data onto the system, we are calling that process ETL. ETL stands for extract, transforms, and load, in which we're going to cover it later, right? So this solution basically means that you prioritize the important data and you keep data that is not that important, still important, but not that important aside first, and process it in an appropriate time. Okay? So that is one of the solutions when the data is are coming in a very high rate. Another one, another one. Sometimes you have a lot of incoming data, right? You have a stream of data pouring onto your data system. Right now, when you write a program to process data, you need all the data to be there first, right? You need to load all the data first, right? And then you process it. If you need all the data first and then process it, we call this type of processing batch processing. So typically, it is easier that you have all the data first, right? You have all the data first and you just process it. It is easier to do batch processing, but that may not be possible for um, for many scenarios, especially the real-time scenario, like for Uber, for those other things, right? For Uber, we want to process the data as soon as possible. We want we want users, we want users to get the feedback in like near real time manners, right? In that case, we cannot just like, okay, batch the data and then process it. We just need to process the data right away. Yeah, right away. Even though like even though it may take longer time, like it may take longer times in like if you view it, if you consider all the times to process data, it may be longer. But if you just try to process the data right away, users get more responsive feedback, right? So let me give you another example. Um, so normally people just like, so when they say that we batch the data first, right, and then we process it, normally it can be faster because you don't need to wait for the data. But if you're going to process in real times, you need to wait for the data. Sorry. You just like, okay, grab data and then process, grab data and then process, you know. And this will be overhead for you that you need to, okay. Well, I'm gonna wait for I need to wait for the data first before I can process it, something like that. No, okay, never mind. Um, oh, but yeah, but that's another thing. Sometimes you have a data coming in a very high rate and you want to process it in real times manner, in a near real times manners. And we call those kind of things a stream data processing. You want to process data as a stream instead of you batch the data first and then you process it all at once, you know. Okay. Um, for the stream data processing, I think I have like a better example, but let me put it out like when we introduce you to these lectures. Okay. Any questions so far? Mm-hmm. So there is a question that for the staging state, we filter at the unimportant and leave it until we use ETL to clear data at the end of the day. Yeah, yeah. It doesn't need to be at the end of the day always. It just depends on like the uh, the system or the business would like to clear that data out. Would like to like use that data or process that data. Any questions? Okay. Well, so that is all about this course. We will learn all the challenges in more detail. Oh, okay. Another questions. The important data during filtering will be used first. That okay. It depends, but the reason why we do staging is something around along that line is that we would like to prioritize some data that we want to process it first right away, and then we leave on the data that is not important enough to be clear later on. It doesn't need to be by ETL. ETL is one of the way to clear those data. There could be other techniques as well, right? We will learn it in when that lectures come. Yeah, but ETL is one of the way, right? Clear? So again, the important data or the data that we would like to prioritize, we usually would like to use process them first, and then there will be a data that we don't need to process it right away. So we may want to leave it in somewhere else first and then process it in an appropriate times or the time that it doesn't have a lot of workload. It doesn't have a lot of load. something like that. Questions? Any questions, comment, concerns before we move on? Okay. Yeah, for the stream data processing, we will talk about it later. Actually, in the further slide, I have one thing, but yeah, we see. All right, so this course, we're going to talk about these three main themes: high volumes, high velocities, high varieties. And we're going to talk about techniques that we're going to use to to tackle these challenges. Which means if you are taking this course, and I would expect you to, let's say, if you get into like some challenges in terms of high volumes, high velocity, high varieties, you have solutions to solve them. Okay. That is the purpose of this course. That is the goal of this course. Right. It, there could be some scenarios where data challenges come from different themes as well. It could be challenges that we have high volume and high velocity at the same times, high volume and high velocity at the same times, or all three at once. That's possible too as well. Okay, you're gonna learn how to deal with all of this through a project. So you need to build a project, right? Which means one thing, one thing is that so I can spoil you right away that the project will be a group project, and you may want to use may want to have more than one computers for each team because we would like to have use multiple computers to demonstrate or the techniques that you're going to implement. Okay. All right. So this course is all about techniques to deal with big data, data partitioning, data aggregation, distributed programming models, flexible data models, file or blob storage, data stagings, ETL, stream data processings. And if you just learn those techniques conceptually, then I feel like okay, you will understand how it works, but you're not gonna have any experience on solving it. Maybe you're gonna have like maybe you may think that you understand it, but you don't see what it is in practical. So that is why you will learn the tools that we're gonna use to do it as well. For the first two, one partitioning and replications, we're gonna use DuckDB. You all have noted, but DuckDB here, I need to put a few remarks here that DuckDB, it can do data partitionings, but it cannot do data replications. But we will use DuckDB to demonstrate how to do replications. Okay. The distributed programming models, if you took big data classes in Thailand, most of them gonna teach you something that they call Hadoop MapReduce. Better courses gonna teach you Spark. I bring out the state of the art things called Ray, and I'm gonna teach you that. Ray is a very new thing that it will definitely be adopted in the futures. It's a lot better than Spark. Okay, so I will teach you Spark, but Ray. But I also gonna teach you Spark because let's say if you are going to the industry, they're gonna ask you whether you can do Spark or not. So that is why I'm going to teach you Spark as well. But I just at least want to demonstrate that there is a new thing that people will definitely be using in the futures, right? Flexible data models. I introduce you three technologies: RockDBs, MongoDB, and Neo4j. MongoDB is very popular. I definitely know. I definitely assume that. I definitely sure that some of you have used it before. Neo4j, perhaps some of you have done it before. RockDB, I don't think many of you had heard about this, but yeah, we're gonna teach you all of these three technologies. For the file and blob storage, we're gonna use something we call Minio, Min.io, Minio. If you have used Amazon AWS, Amazon Web Service before, there is a service called S3, which is basically a Google Drive, but this is a Google Drive that it exposes many APIs. that you can easily write a program and connect with them. Minio is similar to the Amazon S3 that I told you, that I said. Okay. But it is an open source and you can launch Minio on your local machine. The next one is data staging and ETL. I'm going to teach you Duck Lake. Duck Lake is a place that you can, is a system building on top of DuckDB that can help you manage the data, the staging data. Databricks is a cloud data warehouse that is very popular. I believe that it is top in the top 10, perhaps top 5 most like company not sure how to say it, but it is the top 5 data companies by revenues. So this one is really hot. And I would like you to try using it out. Okay. And Databricks can do ETL, this one. The last one is stream data processing. We're going to use Kafka, Apache Kafka. This one is also a popular one. I have used it 5 years ago and it's still used in the industry now today. Okay. So this course, all the techniques will try to do something like this. So Uber has a blog saying that how they built the data platform. So they start from something very, well, before I get into it, forgot. Any questions on this? No, right? I think that you're going to learn a lot of tools, okay? And it help you have a more clear picture of what each technique is. So Uber has published this blog telling about big data platform starting from the first generation of Uber. So in the first generations, what it does is that it's trying to handle 10 terabytes of data, right? I'm not sure whether what this means, right? But it's like terabytes of data. And the constraint is that they would like to process all the data within 2 days, 1 or 2 days. So these are the applications. They want to do city ops, machine learning, do some experiments. They would like to have like some data so that data scientists can do the analytics ad hocly in an ad hoc manners. So these are the applications and the analytics that they want to use. What they do is they have one data warehouse. Data warehouse will be something that we're going to learn in this course as well. But basically, data warehouse, you can right now think about it as a database, as a relational database. So they have this relational database that they will connect it with applications and connect it with analytics. For third year, you know how to connect database with analytics. For second years, you know how to connect your database with the applications because those are your projects, class projects, right? But since the data are coming, I believe the data are coming in very high rate. So that is why they are not storing the data onto the system right away. They're trying to stage some data first. So the data are coming in multiple ways. The first one is coming into Kafka. The data that's coming to Kafka are going to be a stream of data, right? A stream of data. Then it staged data onto cloud storage first. Cloud storage here is Google Drive, not Google Drive. I love to use the word Google Drive because it's very relatable. But for the sake of Uber, they're not going to use Google Drive. They use something like Amazon S3, something like that. They just stage data in the cloud storage first. Okay. They have their own relational database as well. They have their own key values database as well. And it said that it is sharded. Sharded means it does partitioning and horizontal scaling. This is the term that people love to use. sharding, right? Horizontal scaling plus data partitioning equal sharding. So they do sharding here as well to store like many of the databases, right? And then once once uh once they are ready to process data at this stage, they get all the data from multiple places into the ETL process. ETL techniques not only gonna process the staging data, sorry, it also can gather data from multiple places as well. So to give you a heads on, ETL stands for extract, transform, load. Extract means a process that you gather data from multiple places, right? Transform means you want to use the data that you gather and then transform it into another data that is easier for you to use. And load means you load the data that you just transform into a target data system. So extract is you extract data from cloud storage, you extract data from sharded database, you extract data from relational database, you transform them into a format that it is appropriate for the target system. Then you load the transformed data onto the target system so that they can use to do analytics and application easily. Okay. But even though this look fancy, Uber still not satisfied because you see the latency for 24 hours to 48 hours. That's a lot, right? That's a lot. They want something faster, you know. So in the second generations, they improve from 2 days to only 1 day, even though data size are larger, like as 10 petabytes. Okay. So the thing is that you see there's a lot of things going on. We have Vertica here, the data warehouse here that's still used for analytics. We have Spark. You see the Spark that I told you before? Spark is one of the way to do distributed programming, right? So Spark here will gather data from this place, right? Hadoop. Hadoop here is like is also a file storage one or the staging area, right? Staging data. So it gathers data from the staging data that this one, it doesn't need to be on single machine. It typically be on multiple machines. And it gather data from Hadoop and then use Spark to process it and then bring to applications and analytics, right? This part is still the same. The ingestion part, the extract and load part. You see that we don't have transform anymore. This is because transformation takes time. And sometimes we don't have time to transform it. So they just extract them and then load it right away to this part. This part is typically unstructured because we load it right away. So the role of transform here, let me get back. The role of transform here is to, one of the roles of transforming data is to make data, incoming data, be structured so that it is easy to use, right? Data coming from Kafka, it may not be structured. It needs to transform first. So in the second generation, they remove the transforming process and they keep data unstructured or semi-structured. Then for the data that is very important, they can just throw the transformation and send to the data warehouse right away so that they can do analytics. Or if they want the structured data or they want to analyze on the unstructured and semi-structured data, they can just connect to the Spark so that they gather data from this pool right away, whether it is unstructured or semi-structured, and then use processing power to deal with it so that it can send to the applications. Right? For the data that is not prioritized or not important, they just do transformation along the way. Right? Just do it in background, something like that. So this is like the second generations. The third one, pretty similar. But this time it do something that they call incremental ingestion. I'm gonna tell you in the last lectures for this course. Okay. But one thing that I would like you to see is that latencies drop now from 1 day to only an hours or minutes. That's a lot. Even though data size increases. In this course, we call these data pipeline. Is this a pipeline of data, right? Going from one place to another place to another place to another place and bring back to applications. We're going to learn how to build data pipeline like this. Maybe not as cool as Uber, but at least you have a sense of how to build it and how it works. Okay? Questions? I know this slide is quite complicated and technical. Okay. If you have questions on this slide, drop in questions on forum. That's fine. My God, we spent like almost 2 hours. Oh, any questions, comment, concerns? Okay, let's go. That's all for the technical details. So if you're now sleepy or you cannot like put things into the head anymore, then we can get into the cost evaluations, which is not that heavy in terms of technical. Right. So if you cannot follow what on the previous slides, I suggest you put the question on forum, okay? So that we can talk about it. Yeah. And there will be a recording as well. But if you watch the recording and you still don't understand, ask me on forum. So I told you before on the website, right, that the grade comes from assignment 40%, project 40%, final exam 20%. That's all. If you look at the grade breakdowns carefully, you can see that we focus a lot on assignment and project. This is a project heavy class. You need to do a lot of project and assignment. Not a lot of project, one project, but it need to be substantial that I can give you 40%. And um percentage related grade. So this is how I'm gonna grade you. But honestly, it is unlikely that I'm gonna use this table. But if you reach this table, that is the guarantee that you're gonna get this grade. Okay. So if you want to get A as well, just get more than 90. Okay. But again, it is unlikely that I'm gonna use this table. It is likely that I'm gonna do the curving things. So most of you gonna get either B or C plus. Should be along this line. But you need to demonstrate enough efforts and dedications. Okay. If I see that you are like not put enough efforts or dedications, and I can't help you a lot. Okay. All right. Last thing that I want to say, not last thing, we still have another things. So we provide you 3 websites, right? Forum, BigGrade, and course website. Try to access forum and see whether you can access it or not, right? And see whether you see the course as well. BigGrade is the system that you're going to use to submit assignments. So try accessing BigGrade as well. I already like put all of you onto BigGrade. So just try to sign in and then sign in using your KMITL email, okay? And then see whether you can get into the course or not, right? The last one is course website. So forum, it's basically anonymous Q&A platform. You can ask questions anonymously. I would suggest you not DMing me if it is not very personal. Okay, if it is very personal, then that's fine. You can DMing me on Discord, email, whatever you want, right? But if it's not that personal, if it is cost related, then just put it on forum. If you're afraid, just ask anonymously. Okay. BigGrade is a system that I developed to auto grading your assignments. But honestly, for the sake of this course, we are not going to use the auto grading that much. I can say it right away. But we use this to submit your assignment. Okay. Rather than the assignment, it will also show you the grade that you are receiving right now as well. For this course, we're not gonna have grace days, late days. Okay, so you need to submit your assignment on time, right? And not allow late submissions unless you have a very good reasons. Okay, if you really need to submit assignment late, talk with me. Okay, I can give you extension. All right, Course website, okay, just all the stuff, the slides, the course evaluations, the course informations, course description, blah 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 and blah. Okay. Okay. I will overview you to all the assignment that I am planning to give you. Okay, there will be 4 assignments for 40% of the cost. So basically, each assignment will give you 10%, which is a lot, right? So the first assignment, perhaps the easiest one. The first assignment is that I'm just gonna let you get a chance to explore the various big data applications. Okay, so there is a student asked me whether there will be a checkout or not. For the third year, you may not be familiar with this. For the second year, I believe that you you know this already, right? For this course, I mean, it's an elective course, so I'm not gonna be that nitty gritty. So there will be no checkout. There will be no checkout. But for the project, I mean, you need to talk with me a lot. So yeah, but basically there will be no checkout. Checkout means an interview to check whether you understand your assignment, your submission or not. Okay, but there will be no checkout for this course. Okay. So for the assignment number one, I will give you a chance to explore various big data applications nowadays, right? So that you get sense of what the hell is big data and what can big data do and why do we need to use big data, right? Or maybe when you should gather a lot of data, when you should just use less data, something like that. Assignment one released today. Actually, I already released it on Big Grade already. So I will provide you an information at the end of this class. The assignment. This will be a programming assignment. I told you earlier that DuckDB cannot do horizontal scaling or sharding. I will assign you to make it be able to do sharding. But you don't need to modify DuckDB, okay, directly. But that is very hard. And I mean, I didn't say that you cannot do it, but it's just like it's gonna take a lot of times. And I think there is a better way to demonstrate you to to do it, right? So you will build a program that can manage multiple DuckDB instances across multiple machines. So imagine you have 3 computers. Each computer have DuckDB, DuckDB, DuckDB. I want you to write a software that coordinate between these 3 machines. That's it. Right. So that is the second assignment. I will give you with details as well. So don't no need to be worried. I mean, you may think that, oh my God, this is how I'm gonna do this right now. No worry, I will give you with details first. Okay, before I assign you this assignment. Right? And this is programming assignment. So you need to write a program. Unfortunately, you need to write a program, okay? Okay, there's questions that for the assignments, we will do one per week, right? Yeah. It's not one per week as well. We have 4 assignments. It is distributed across the semesters. So approximately, I give you 2 weeks per each assignment. And you can check the schedules on the course website to see whether when I'm gonna release each assignment. Okay. The next one is a distributed data processing. So you use Ray data to write distributed programs. Distributed program means a program that coordinate between multiple machines, right? Data from multiple machines. Yeah, that's where we programming assignment. The fourth one is a programming assignment that I would like you to develop a database applications. So this will be pretty similar to the projects. The second year, the project that I gave to second years and the third years in the database course, write an applications that connect to the database. But I will ask you to use certain technologies like RockDB, MongoDB, and Neo4j. You need to use all of them in a single applications. So you need to think about. You don't need to think about it. I will give you an assignment so that you know how to use each one. Right? Again, programming assignment. All right. That is all the overview of all the assignments. The next one is project. So for this course, I give you two options for the project. The first one is you may want to form a team to create a working solutions to solve problems related to big data. Okay. Um, the second option is a research option. You will not, if you go into this track, it's not about creating a working solution. It's about think about a new concept or method that solves problem in big data. So the two things, right? If you want to go into industries, I suggest the first one. If you want to gain deeper understanding, or if you want to study abroad, I suggest you could go on the second one. Okay, but still, if you are since you have learned with me already, right? You have taken my classes. I really love you to identify problems. I talk about the word problems a lot, right? Because that is a key. If you don't know which problem you are solving, you mostly gonna get lost because you cannot verify whether you have solved the problem or not. So both tracks still require you to identify problems. It's just different problems. If you do application, you want to identify business problems, um, social problems, a problem in real life that is relatable to us as typical users. But if you do research, you can also use those problems as well, but you can also use a problem in the big data, or maybe the idea that I demonstrate to you in the lectures. You may think that, hey, I can give you a better solution for this one. That is also a research, right? You still need to present the problems in the project proposal presentations. So you have the project proposal presentation. Okay. For the application track, team up to 5 people. So I believe that we have 40 something, 40 each students. Not sure whether some of you gonna drop on it or not, this course or not. So yeah, but basically we have like I can allow you to form team up to 5 people. Okay, up to means you could have a team of 1 people as well. Solo, so you can do it solo as well. Or you may want to do it 5 as well, 3 as well, 4 as well. That's fine. Depends on all of you. Okay. So the application track is you basically use technologies I introduced in the class or similar technologies and build working application that can solve or mitigate problems related to big data. Okay. The next track is a research track. Is this a solo or dual project? So basically 1 or 2 people. Okay. You need to propose a new concept method that solves problem in big data. I don't want a working applications. You just need a new concept or a method, but you need to evaluate that this is correct. So still you need to write something, you need to implement something. Okay. If you don't know how to do research, talk with me. Okay. Try to talk with me early and let me inspire you. Okay. I hope I can inspire you. Right. If your work is good enough, I would try to push you to get some academic paper. And I would say that this is really important if you want to go abroad, study abroad. Having a paper will give you an edge. Okay. All right. Uh, any questions on the application tracks and the research track? Good, right? Good. Everything is good, right? Okay. Okay. The timeline. So right after the midterm week, since we don't have the midterm exam, right? So use the time for starting midterm for this course to do proposal. And you need to present your proposal the week after the midterm. Since this course is on Monday, so basically after the Sunday, midterm on Sunday, then right after that, you need to present it right away. Treat it as a midterm exam. You treat it as a midterm exam. Again, if you're familiar with me, you know that for each presentation, it is better that you show me the slides beforehand, not one day before, just maybe a week before, so that I can suggest you how to fix it. And your presentation is going to be smoother. Okay. Every 2 weeks after the proposals, you need to present your progress in class. So we call it a project progress presentations. So we're gonna have two progress presentations after the proposals. So basically now we have three presentations. And last one, after 6 weeks from the proposals, it will be the project presentation. So basically for the project, you will present it 4 times. 4 times, okay? For the progress presentation, it will be a small short presentation, so you don't need to care. You need to care about it, but you don't need to be worried about it that much. For the proposal and the final, this one is what you need to care. And since this will be a 6 week project, I don't expect you a lot. I don't expect you to build something very a lot of things. You just need to convince me in the proposal that hey, this project is suitable for 5 people with 6 weeks, something like that. Okay. All right. Any questions regarding the project? Well, if you have questions, then drop in on forum. All right. If you want to ask right now, that's fine as well. You have one project. It is called only one project, 4 assignments and one project. Yeah, you can choose either. You have an opportunity to choose whether you want to do applications or research. Yeah, you don't need to do both of them. Just need to do one of them that you think that it's gonna suit you. I can say it right away that application is easier. If you do research, I expect something more. Okay. I expect something that it's it is it it can solve the problem academically. Let's say if you do application and you work alone, um, yeah. So when you present your proposal, then you just need to say that, hey, I'm working. This is the numbers of people that in my team, and then this is 6 week. So you just need to present a application that it fits into this um times and effort and people, So yeah, basically the criteria go down if you're working alone. But still, you need to deliver a working application. There will be a certain requirement that you need to meet. So for the project, before you submit the proposal, before you present the proposal, come and talk with me first, okay? I really want to talk with you before you propose a project. If you don't talk with me, it will be very hard to um for me and for you to know whether our expectation met or not. A student asking me whether you need to start me more on UX UI and JavaScript HTML too. No, applications here means doesn't mean that you need to build web application or mobile applications. It just thing that can solve real world problems. It can be CLI. I don't mind. I don't if you can build web application, mobile application, that's cool. That's cool. But it depends on uh whether I don't care about the interface that much, the client interface that much. Okay. So it can just be a CLI programs. Any questions on project? A student asked me whether they need to start project before midterms and present after midterms. Only project proposals that you need to start before midterm. I mean, if you can start before midterm, that's cool. But the requirement is that only project proposal need to be formed, and it should be formed before midterms and present right after immediately after midterm. So basically, you should think about the idea before the midterms. So let me give you an advice. When you think about application project, you have only 6 weeks. So you should not think about the thing that is very crazy. Like, for example, I want to build the Uber that I show you. No, that is too if you can do it, if you think that you can do it, I'm not gonna hold you on. But for me, think about something small. But it can exercise your it can like demonstrate whether you understand the cost concepts or not, the concept that introduced to you or not. Okay. Any problems. It can be any problems. And if you talk with me, I can help you scope it down. It can be so basically it can be any problems in the world. But if you want to present to me, you need to have an evidence to show me whether the problem exists. Okay. There is no restriction whether I want the problem in a specific domain. No, it can be in any domain. Any questions rather than this? Nung, are you still there?
Yeah,
Cool. Yeah. Nung, how was the class there? Are students sleepy?
no, student is very active, very active.
Right. This students asked me whether can I ask about the lecture today. Sure things. So drop in the chat, okay? If you want to ask me and you want me to answer to you in the lectures, but if you don't need, if it is not urgent, then you can also put it on the forum as well, right? But sure things. You can ask me anything, really anything. All right. Okay. Um, so there is a student asked me about data replication. So so there are two methods on replicating data, two versions of it. The first one is that um, let's say we partition data into 1, 2, 3, and 4, right? 4 chunks of data. The first version is that we have 3 machines. We store data on machine number. We have 3 machines, but we have 4 chunks. So the number mismatch, right? But we store the first and the second. We store the first and the second chunks on the first machine. We copy. We also copy the second data, and we also store the third data on the second machines. We also put on third and fourth data on the third machines. So this is the first approach. The good thing for this approach is that you need less machine, right? Well, it's not. Yeah. Basically, you use less machines. This is also data replication as well, right? But the point is that let's say if the first machine fell, you lose the access to the first chunk of data, right? If you're lucky that the second machine fell, you can still have another copy of the second and the third data on the other machines. So it's more like the first approach, it's a little bit more fragile than the second approach. So the second approach that the students asked me, show to me is that I believe we have 8 machines. And for each pair of machine, we store the same data. So basically for the chunk number one, we store it on the first machine and on the second machines. For the second chunk of data, we store it on the third and the fourth. For the third chunk of data, we store it on the on the fifth and the sixth. For the fourth chunk of data, we store it on the last 2 machines, right? For this approach, basically for each data, we store it onto 2 machines. If one machine fail, we still can get access to that to that data, right? Because we also copy it onto another machines. Both of them are replications, but it's just whether which techniques are more reliable or will give you more in terms of software we call it an availabilities, a degree of availabilities. Okay, not sure whether that is clear or not. I mean, honestly, I haven't saw your question, so I'm not sure whether I answer your question or not. Okay, cool. But that is good. That is good. Actually, this is one of the techniques that I will introduce to you in the data replication class as well. But since you asked me first, and that's cool. That's nice. Okay, let's talk about the first assignment that I have already released. This is not a programming assignment, so I believe that it is not that hard for many of you, but but it may be you may think that maybe I'm a little bit too nitty gritty here, but let's see. So the assignment number one, since you will be doing a project, the project must be related to big data. I'm afraid that you may not be familiar with big data that much. So I will let you explore existing big data use cases and challenges. To let you do it, there is one book that is very interesting from Oracle. If you don't know Oracle is basically the first commercial relational database company. The co-founder of the Oracle, his name is Ray Ellison. In this year, he just be the richest person in the world before Musk get like those trillion pay things, you know. Yeah. So basically, they published this book containing a lot of real world use cases for big data. You may think that, oh, it's a book. Oh my gosh. But for me, this book is very easy to read. There's not a lot of text. There's not a lot of text and there's not a lot of technical details. So I believe that you all can read it easily and understand and see different use cases from it. Okay. So what I want to ask you is you picked 3 different use cases. So in the book, there will be like 18 or 20 use cases. You pick 3 different use cases that you are interested in. Well, if you think that you have other sources that give you better details, you don't need to use the book. Okay? You pick 3 different use cases. It might be different. Different here means that difference in terms of challenges. No, it should not be different in terms of challenges. It should be different in terms of domains or the problems. I want you to pick 3 different problems or domains of problems. You know, it can be three different solutions as well. That's fine as well. But these three things must not be related. I mean, it's hard to say whether they are related or not. It's so just saying that they are different. They are not like they are non-trivially different. You know, it should not be just like the first one is Uber, the second one is Grab, the third one is Lineman. No, 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 I don't want that. That is what I want to say. Just want like three different domains so that you can see it. Like you have like different perspectives of how each industries or each domains tackle big data. Okay. For each use case, answer the following questions. What is their original problems or the problem that they faces? How can big data solve their problems? And when they use big data, what are the challenges that they encounter? And from your perspective, how would you solve these challenges? This one, I don't expect a lot. I don't expect that you need to form a very well-formed, well-detailed solutions. Okay, just an idea. That's just an idea is fine. One or two statements, but you need to describe your rationale why you think that this approach will solve these challenges. Okay, you need to write one essay to describe all the answers. When I say one essay, it doesn't mean one essay for each use case. It's one essay for all use cases. So basically, just one essay describing all three use cases, answering all these questions. Okay. Um. Uh. You're not allowed to use iterative AI to write the essay for you, but you can use iterative AI to do proofreadings. Okay. Um. The student asked me whether I am are they allowed to send the essay to you or TA before submitting? Yes, before the due date. Okay, after the due date, I cannot help you. All right, but you can send to me first before you submit, so that you can get the feedback before times. So to submit it, all of you are not familiar with BitGrade. I believe that only first year have used it before. So when you submit uh, things onto BitGrade, BitGrade only accept one format, which is a zip file. So you follow this instruction carefully, okay? Strictly as well. So you write everything, whether Microsoft Words or Google Docs, that's fine. You save them as a PDF file. Okay, save them as a PDF file. You name the file with your student ID. Okay, so now you get one PDF file, right? Then you zip your PDF file as a zip. It must be zip file like ZIP or ZIP, the zip files. And you submit the zip file on the BitGrade. The due date is on December 7th, midnight. So basically, it is a midnight of the December 8th. But don't submit it last minute, okay? Right? So basically, 2 weeks from now, if I remember correctly. Let me check the calendars. Yeah, 2 weeks from now. So it's due on Sunday, right? Sunday the night between Sunday and Monday. Sunday, yeah. So there's questions asking me whether AI proofreadings does it include grammar checking as well. Uh you can use it to correct grammars. I don't basically mind about grammar, but if it's not that bad, okay. If you write something that I cannot understand it, then that's gonna affect your grade. Okay. So the trick is you send to me earlier so that you can get feedback from me. Okay. Again, if you in my course, you are free to talk with me. You're free to get feedback from me. You need to use me as much as you possible. Okay. So send to me first, DMing me on Discord, email, I will give you feedback, a quick feedback, so that in order to make sure that this is a good submission. Right? Uh, the, the the important thing about this is that I am not grading you only on the essay. The essay is not the only thing. So, given your essay, you need to do lightning talk as well. 3 minutes lightning talk. So basically, just a little quick talk presentation. It's a quick presentation that you present, oh, this is the problem I found, and this is a solution that I propose. This is like the big data challenges that I encounters, something like that. And this is like the way that I would suggest. So basically, the answer to the questions. A lightning talk starting from December 12th, 22. So basically, when I am on site. So before the end of each class, I will allocate 20 minutes. You do a quick, it's a quick lightning talk. So it's very quick that you give the presentation to your friends. So your friends also aware of other use cases as well. Right. So each of you will be presenting one of the pick use cases. Only one of them. So I make you pick three. Then from three, I will help you. I will help you pick one of these three. Okay. And I will tell you that this is what you need to present. And you just need to form a 3 minute presentation and present it to your friends. So potentially it will be 5 or 6 students per week if no one just drop it. So which means right now we have 45 people, right? So we should take like 9 weeks. It will be a little bit sad if you need to have 2 presentations. It is possible that you could have 2 presentations on the same week as well. Let's say if you have to do project proposals and the what else? And the lightning talk. But the lightning talk should be easy, you know. Like basically, this is to make sure that you understand the thing that you wrote. Okay. Another thing is I may invite professors to here, not Carnegie Mellon, Texas Tech, in which I believe that the second year you have known him, to give a talk as well, a guest lecture as well, if I can allocate him a time, and if he are free, if he is free, so he basically do a research in big data. So he is like a big data guy, and he teach big data course in the States. So I'm planning to invite him to give a guest lecture as well, right? So you can see like broader view of what people are doing right now in terms of big data. Okay. And that's it for the assignmentable one. Again, it's still on December 7th. So don't forget, okay, to submit it. I will post it on forum as well. Right. The next lecture, next week, we got to talk about the evolutions of data technologies. Why do we need to talk about this? This is because, this course, we will learn we will learn a lot of data technologies. And it is better for you to know the type of data technology first. And for me, it is very easy to understand if you learn it from the history. If you learn it from like the beginnings of how data technologies are built, why they are built, why they were built, and then how they are evolved, so that we have the nowadays data technologies right now. Okay. That is for the lectures. Oh my God, I didn't thought that I'm gonna spend like 2 hours and almost a half. Yeah, enjoy the course. And again, this course is very new, so expect there could be some buggy things that I need to fix along the line. Right? So thank you so much, and see you next week, Monday. Okay? Any question, comment, concerns? No. So thank you very much. So let me stop recording.